Are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft. And now in this video, we are going to move ahead from our discussion with the first scheduling algorithm, which was first come, first serve. And now we are going to move ahead and talk about the next scheduling algorithm, which is shortest job first scheduling. Okay, so let's quickly get started. Always remember that the best way to learn these algorithms is always by their name. Okay, because the name itself gives a lot of idea about how the scheduling of the processes work in that algorithm. So let's see and read the problem and read the statement first. A different approach to CPU scheduling is the shortest job first scheduling. Okay, this algorithm basically is associated with each process the length of the latter's next CPU burst. Okay, now when the CPU is available, it is always assigned to the process that has the smallest next CPU burst. Okay, if the two processes have the same CPU burst, first come first serve scheduling is usually used to break the tie. Okay, note that a more appropriate term would be the shortest next CPU burst, because the scheduling is done by examining the length of the next CPU burst of a process rather than its total length. Okay, so let's take a look and understand this using an example itself. So here, out of all the processes which are available, we always usually pick the one which has the lowest burst time. Okay, so here we have been given a processes and we have also been given the burst time. Let me quickly write this down. P1, P2, P3, P4, and it says 6873. And also assume that the arrival time for all of them is same, which is at 0th instance only. So at the 0th instance itself, all of them basically came in the ready queue. Okay, so what happens over here is, when we will try to make a Gantt chart for this, okay, it will go something like this. So first, out of all the process we have, which one has the shortest burst time? This. So first we'll execute P4, 0 to 3. Okay. And here, what will happen is, the next one that we will execute is this, P1, because it has the shortest burst time. So this is 9. Okay. Then we have P3, which will take us to 16, and then in the end the longest burst time process is executed, which is this. Okay, so this is how we do this. We don't care about the fact that, you know, when the processes came in the system, if there are multiple processes that came at the very first time, right, the one with the shortest job will be executed first. Okay, so here in this case, the waiting time for the process P4 is 0, for the process P1 is 3, for the process P3 is 9. Why? Because it had to wait 9 seconds in order to get started. And for P2 process, it's going to be 16. So what will be the average waiting time over here? It will be 3 plus 16 plus 9 plus 0 divided by 4. Okay, and this will basically come out to be 28 by 4. Okay, and which in itself turns out to be 7 milliseconds. So every process on an average has to wait for 7 milliseconds in order to basically get executed. Okay, that's what the overall idea is, and that is how we work with this algorithm. Okay, now remember over here a few things is, shortest job first is actually the best algorithm. I'm writing this down. It is actually one of the best algorithm for having minimum waiting time, because the shorter processes are executing first and we are shifting the long processes with larger burst time towards the end. Okay, so that is what the overall idea is. Another thing to remember over here is to successfully implement this algorithm, right? The burst time, okay, of the processes should be known by the processor in advance, okay? Because you have to execute the one with the shortest burst time first. So for that, you should know in advance the burst time for all the algorithms, okay? So remember to successfully implement this, you should, or you should, not the processor should. The processor should know the burst time of all the processes in advance, which in a practical way is not always possible. Remember that. Okay. And again, this kind of a scheduling algorithm is optimized only when the arrival time for all the processes is same. Because if the arrival time is different, then it may happen that, you know, this process was the shortest one, but it was actually coming at arrival time of 8. Okay. Then it did not really make sense. Then you have to execute the longer process only first. Okay, so to execute and to take the most advantage of shortest job first algorithm, it's advisable and more preferable that you have the arrival time same, because if the arrival times are different, then we cannot even execute a process even if it is short, because it's not even in the queue right now. So another point is this scheduling algorithm is optimal if all processes are available at the same time. Okay, and the last point over here is that this SJF, shortest job first algorithm, can be of two types. So if you remember, the first come first serve scheduling algorithm was non-preemptive, but in shortest job first there are two versions to it. It can be non-preemptive also, okay, and it can be preemptive as well. Okay, so there are both versions of this algorithm that basically exist over here. Okay, in the non-preemptive version, the process which is coming first will be the one that will be executed first as well. But in the preemptive version, it may so happen that the process which basically came first, right, it's being executed, but another process with a shorter wait time basically came, and hence the execution for that happened faster. Okay, what you can see over here is, let's also take the same example we took earlier to compare the waiting time as well. Okay, you remember we took this example for process P1, P2, P3, P4, and here the waiting time using the first come first serve came out to be 18.5. Let's see what the output comes in if the process, if we are using shortest job first. The arrival time for all of them is same. So which one will you execute first? It will be P4. Then you will execute P2. Right? Then you will execute P3. Then you will execute P1. So what is the waiting time? For P0, P4 it's 0, for P2 it's 2, for P3 it's 5, and P4 it's 11. So this is and you can see how optimized it is. Correct? Starting from 8.5 milliseconds, we have considerably reduced to 4.5. And like I was saying, that's the very reason we don't prefer first come, first serve a lot. Although first come and first serve is very easy to understand, but you can very clearly see over here that it is not at all optimized. Using shortest job first, we can actually take down the waiting time to 4.5 seconds. Okay, and I hope this is clear to everyone as well. And this is the non-preemptive version of shortest job first scheduling algorithm. Okay, let's also see a preemptive version of shortest job first scheduling. Okay, let's take an example for that as well. So preemptive, by the name, remember that if a process with the higher priority or with a lower burst time comes first, the current process will be interrupted and that process will be allowed to execute. So let's say we have process, we have arrival time, and we have burst time. Now see very clearly in this, carefully. So we have the process P1, P2, P3, P4, 0. Let's say here this is 1, 2, 3. Burst time is 6, 4, 6 and 1. Okay, ठीक है. अब ऐसे दिखते हैं यहाँ पर. This is at t equal to 0. So at t equal to 0, there is only one process P1, correct? There is only one process P1 in the ready or the waiting queue. So what we will do is, as it is the only process, we will execute it. Okay. So at t equal to 1, we only have 5 more, I would say execution units of process P1 to execute. But at the time t equal to 1, there is another process which comes into the queue, right? There is another process which comes into the queue, and that the waiting time of this, the burst time of this is less than the burst time of the left time of P1. Okay, since that happens, we basically start executing P2 over here and P1 is basically stopped. Now at t equal to 2, we still have 3 more cycles of P2 to basically execute. But at t equal to 2, there is another process that comes in as well, which is P3, and its burst time is 6. Now we have the burst time 5, 3, 6 and 1. Okay, 1 is still not there because it's not in the queue right now. Out of all of these 3, which one is having the less waiting time? We have P2. So P2 will be allowed to execute over here only. Okay. Now at t is equal to 3, P2 still has 2 executions left of it, and here P4 basically comes, which has a time of 1. Now out of all of these, P1 is basically the one which has the lowest time over here. So in this situation, what will happen is P4 will be allowed to execute and P2 will be stopped. Because of which we can say over here that this is at 4, and with this we have 5, 2, 6 and 0 cycles left for all the processes. Since P1 got completed in one cycle itself, we do not have anything left. Okay. Now in the next cycle, what you will do is, now at this point of time, nothing new is added to the queue, right? At t is equal to 4, nothing new is in the queue. Only the processes which were in the queue are still in the queue left. So nothing new is added. So P2 now can execute with interruption because it will always be the smallest. So it will be P2 and it will be P2. Okay. After this, we will execute P1 process, right? In this case, what will happen over here is we have the P1 process. So P1 process will execute for 5 units. Okay. And after that, we basically have the P3 process, okay, which still has 6 cycles left of it. Okay, because P3 was actually never allowed to execute. So this will be for, okay. So this is how the preemptive version of shortest job scheduling works. If a process with the shorter wait time basically comes first, right, or the shorter burst time comes first, the current process that is being executed is basically, and the other process is allowed to execute first. Okay. Whereas in the previous case, no matter the process comes in, if any other process comes in later also, right, it will have to wait for the completion of the other processes and then only it can come in. So it cannot just interrupt in between and execute some steps for it and move back. Okay. It will have to wait for the entire cycle to get executed. This is just like a more clear way of writing this. Okay, so that's how basically the overall time works and the overall process works for the waiting time of the algorithms. Okay, so I hope this is clear to everyone how the preemptive version also works and how the non-preemptive version also works over here, as it is very, very important for your understanding. Okay, sometimes in interviews and in test, you might be asked the preemptive version or the non-preemptive version. So for that, you should know both the processes as well. And now one more thing over here, as in how to calculate the waiting time in terms of preemptive as well. Okay, so that can be a little different from what we have been doing earlier and a slightly typical as well in terms of how you will do it. So you can use the formulas that we have seen. So first you mention the exit time, okay, for the algorithm. That means the completion time. That means when do they really exit. For that, you can see that P1 basically ends at 11, okay, and P2 ends at 6, okay, and P3 basically ends at 17, okay, and P4 basically ends at 4, okay. So now that will be your exit time over here. Using that, calculate the turnaround time. And the turnaround time here would be, the formula for that is exit time minus the arrival time, correct? So here turnaround time will be exit minus arrival, which is 11, 6 minus 1 is 5, 17 minus 2 is 15, and 4 minus 3 is 1, correct? And now what is the formula for waiting time? Right, it is nothing but turnaround time minus the burst time. So waiting time will be turnaround time minus the burst time. 11 minus 6 is 5, 5 minus 4 is 1, and 15 minus 6 is 9, and 1 minus 1 is 0, and which is true as well. You can see process P4 arrived in the system at 3 and it got executed at 3 only. So the waiting time is 0. Okay, another one. Here we have, let's say, the process P2. Okay, now for the process P2, what time it arrived in the system? 1. And at this instance, it got started at the instance 1 only. And then it had to wait for 1 second to basically continue for its execution. Hence, the waiting time is 1. And then after that, let's say for P1 over here, okay. For P1, its arrival time was 0. So here there was no waiting time because it immediately got started. After that, it had to wait for good 5 milliseconds in order to continue for its execution. Hence the answer is 5. And the last one is P3. Okay. Now the P3 did not get ever executed over here. It basically started after 11 seconds as well. Hence the waiting time over here, let's see. Okay, so for P3, what you will see over here is that its turnaround time, right? Total time into the waiting that went, which was the exit time over here for this process was 17. So the exit time was 17 and minus the arrival time was 2. That means it came somewhere here, right? But it actually exited the system after executing all of its processes. So the turnaround time here was 15. And now you have to basically take the turnaround time and minus the burst time from it. Okay, that means the burst time was what? 6 over here. So we do 15 minus 6, which is 9. And it makes sense also because the process came over here at 2 instance, but it had to wait till 11. Okay, so it had to wait for 9 milliseconds over here to get its execution. Okay, so this is how you calculate the waiting time over here. Use these formulas and it will become actually a lot easier to calculate this. All right. So I hope this is clear to everyone and you've understood in detail what shortest job first scheduling as an algorithm is. Thank you so much for taking a look at this video. And now in the next video, we'll talk about our next algorithm, which is priority scheduling. So please, I highly request all of you to practice a lot, right? Take a lot of examples. Until and unless you take examples, by just looking at it, it will not make a lot sense to you. But once you've actually figured out, right, once you've actually taken multiple examples to do this, then it will become absolutely clear and it's always good to move forward after that. All right. So thank you so much for taking a look at this video and I will meet you in the next one. Bye.